Good morning to my lecturers and fellow markers. Today I would like to present on my FYRP1 topics, which is the effect of wet-dry exposure on tensile performance of jute fiber mat reinforced polymers. Before I start, I'd like to introduce myself. My name is Phang Jie and I'm from Mechanical Engineering. My supervisor is Dr. Charlie Xia. First, for the introduction, in recent years, natural fibers are widely used as the reinforcement in polymer composite materials, and it is commonly used in structural retrofitting applications, which is constructions, and with the depleting petroleum resources and increasing environmental awareness, there is a growing interest in the use of natural derived alternatives such as natural fibers. Okay. Jute fibers have been a popular choice for fiber composite as it has good mechanical properties. Okay. Next is the problem statement. The use of natural fiber composite in building construction. Also, the presence of water pulse potential derivatives conserved for natural materials. Okay. As for the end and objective, is to analyze the tensile behavior of jute fiber reinforced polymers. Also, to perform analysis to predict the mechanical properties of jute fiber reinforced polymers on wet-dry cycles, and to investigate how the moisture content will affect the tensile behavior of jute fiber reinforced polymers. Okay, as for the research question, first is, will the mechanical properties become higher after undergo wet-dry cycles as it soaks in water and absorbs the moisture content in it? Also, what will happen to the specimen that has higher moisture content? Will it be higher in tensions or lower? Okay, next is the literature review. First, jute fibers belong to Tiliaceae families, which consist of more than 30 capsulary species of jute. Jute is a fiber which is long, soft, and shiny, and that can be resolved into strong and coarse thread. And there are two more known species of jute fiber, which are Crocus capsularis, which are also known as white jute, and Crocus obliteratus, which is also known as Tosa jute. And jute is mainly produced in Asia, which contribute around 95% of total jute production in the world. And it is the second most natural and biodegradable fibers among all fibers. Okay. The advantages of using jute fiber is environmental friendly, it's biodegradable, it's low in cost, and the main properties are good thermal properties, high toughness and durability, and it is very flexible. As for disadvantages, the moisture absorption is high and it has high polar natures. For jute fiber composite, the applications are construction industries, automotive, aerospace, and machineries. Okay. Now for the methodology. For the fabrication, we're using hand layout methods, which are used by cutting layers of fiber sheet and spread with mixture of hardened epoxy. And adding another layers of fibrous sheet and by continuous until the thickness achieved, and then is fabricated and cut into based on the ASTM standard. As for the conditioning process, we mainly contain 5 to 10 cycles, which is for wet. For the wet cycles is soaked in water for around 2 days, and for dry cycles is heat and dry out in oven for around 2 days or so. And then we do testing on the mechanical testing machines for the tensile test. We do testing for different numbers of wet dry cycles to see the difference and taking up the readings. After that, we do the FEA analysis to show the comparison between the actual work and the analysis simulations. Is it the same? Okay. As for the future work, the tensor test simulation of proposed design using FEA analysis, also to investigate on the effect of the number of vector cycles on the specimen to see the difference between them, also to incorporate the failures model prediction in analysis, as they have been different type of failure model predictions to see the failures occurs in red. Okay. Next is my reference. I show the reference, some of the reference in the slide. There are 2 of them, which is mainly used by me. Okay, and that's all for my presentation. Thank you.